And then this way. Then see, it took it away. It's still running in the background, but you know the script on the side is not there. Normally it has a script. Oh yeah. All right, we'll get started here. 6:30, time to get going here. Code of conduct item of the week is to maintain cleanliness and condition of vehicles and equipment. So something to keep in mind for this week. Try to pick things up a little bit around your vehicle. I'll think of that in my own vehicle because I know that my little Jeep is a little small for all the stuff I put in it. There's that mosquito. Scared him away anyway. So we're going to talk about planning the lift here in a couple minutes. And we have a returning employee, Tyler Wells. Is Tyler here? Welcome back, Tyler. And vehicle registrations are in. Check with Larry.
Still got plenty.
Plenty?
Plenty.
Yep. Extras. Okay. So check with Larry because you might be out of date. So for our discussion this week, technical things, we're continuing on fluid mechanics and pumps. And we've been talking about kind of pressurized systems for a little while, which are kind of the simpler of simpler of systems because you put a pump on it, it's confined, the pressure is kind of equal inside of the pipe and everything. What's a little more challenging is the open channel flow. So we're not going to get into a lot of details on how to compute flow for a certain situation, but you can imagine water's flowing downhill. Sometimes it might even be stacked up on the uphill side and not so much on the downhill side. It adds more drive to it and everything. But kind of a convenient thing about open channel stuff, and think about a brook and thinking about needing to bypass a brook for bypass pumping. What do you do to figure out the flow? Well, it's pretty simple, isn't it? Because you can actually measure the velocity. So like sometimes I'll take a stick or something and I'll toss it in. I'll say, oh, that's about 8 feet from there to there, and time it down. Okay, so it can come up with a velocity of the water. Once you know the velocity of the water, you can kind of estimate the area of the channel, and you can come up with a volume. Hopefully it's something you can pump. The example I use isn't very pumpable, I'd say. I said, okay, let's say that we have, let me show you. Oops. So we get a velocity, right? So I measured the velocity. I said, for the example, let's say it came out to 3 feet a second, which is moving right along, right? And then the area, I said, is 10 feet, being this width 10 by 1 foot deep. That's 30 square. I think I had a mistake. It should have been 3 there. Ray, where are you?
Yeah, that doesn't make sense.
My intent was to have 3 feet there. So 3 foot high by 10 foot wide. So 30 square feet, that's a lot of area. That's why the number comes out so big. And you multiply that area times the velocity, and you get a Q, or a flow. So if we are a 30 foot square area times 3 feet per second, that's 90 cubic feet per second. And you see I have the dimensions all resolved here. So I have cubic foot per second, and I change it seconds, 60 seconds per minute, and 7.48 gallons per cubic foot. We're up to 40,000 gallons a minute. That's more than obviously most pumps. But that's 3 foot deep. And if I'd had 1 foot, which was my original intent, it would have been a third of that, because it would have been a third less volume. So a third less volume, that's like 10,000. Even that's a 12-inch pump. So a lot of water. But this just shows you that you can look at a stream, and especially one in a confined area with kind of a reasonably even flow, and just predict the, kind of estimate the size of it, where the water's passing through, and the velocity. It's all about velocity times area. It gives you a flow. Okay, we have an update from the CCTA downtown bus terminal. We're contracted by PC Construction for the site and concrete work down there on Cherry Street. Cherry, and actually St. Paul, from Cherry to Pearl. And the building excavation is just wrapping up, so we can start concrete construction, which is next. and by us. And then the excavation is 100-foot long by 30-foot wide and 14 feet deep, and even deeper at the elevator pit, which is 17. And the excavation is braced by hollow bar soil nails and a whaler beam at the north end. Here we are driving, I believe that's an H pile. Looks like an H pile we're driving. We had several sheet piles in there. Kind of a dark picture in the shape, but that was some of the driving process. And then we had the hollow bar drilling process, which the drill attachment for the 230 excavator. Drill in this hollow bar and we inject grout as we drill. The bar has a sacrificial tip. So there's a little grout plant. That's a colloidal grout plant, like we talked about before. The colloidal mixing breaks down the molecules and hydrates it better and more efficiently, and breaks down the fine particles for the mixing of the grout. And it has a pump on it for pumping it into into the end of the hollow bar. So we drill grout at the same time. It forms a real nice bond between the bar and the soil. And then here we are yesterday morning, I believe, excavating down close to subgrade. That little excavator is going to get trapped, I think, down there. So that's what we got for project, and Matt's going to talk about lifting plans, our kind of concluding our rigging series here.
Thanks, Ken.
Good morning. Hey, plenty of room, guys. We got seats. I know a nice rainy day, so I'm sure we have a packed house. Good morning. We got seats up front. There's seats next to Harvey. Harvey's all sitting by himself. So. No one seems to sit next to Harvey today. So this kind of concludes our rigging, and it's just kind of rules of rigging and the things that we need to plan for when we're using either the crane or even an excavator or a loader, anything to do material handling out there in the field. Is just proper rigging techniques. We kind of go over all the inspections, all the different types of hitches. Now it's just really making sure that you have a good plan, good game plan moving forward about how we're going to pick and move all that stuff. So again, and I teach it in all of our qualified rigger stuff, what's the most important part of rigging?
Knowing the weight.
Knowing what you're picking. What's the weight of it? How much is that weight? Everything starts there. So once you know the weight, then you can pick out the rigging and the hitches and everything like that. The most important thing is everyone should have a rough idea what the weight is. And the tool crib downstairs, and I can print out. We have just some standard weights that we've made up before, of the weights of steel, different types of steel plates, weight of concrete, all wood, and all that stuff. Just a good general idea. You just figure out square footage, and you can figure out kind of rough weights. But again, usually you have trucks and trailer loads, stuff like that. They'll have a rough idea what that picks as well. And then know the center of gravity of the load. You know, do those pre-pick, see what it's doing with it, a couple inches off the ground. Different types of things that we can use, such as that chain fall, like we saw in the video last week, was able to secure the load and make it nice and center. Make the load attachment above the center of gravity of the load. Select the hitch that will hold and control it. Last week talked a lot about the hitches. Know the rated capacity of slings in the hardware. Again, the shackles that you use, making sure that the shackles, again, are more than the working load limit of what you're picking, with the working load limit of each sling device, wire, rope, synthetic, or chain, your shackles, your hooks, all that. You got to look at all that stuff before we start picking. Select the sling that's best suited for the load. You know, if it's a basket hitch, it's a vertical, a 4-leg, 3-leg, whatever it may be, make sure it's suited for the load. Inspect all rigging before it's lift. Protect the slings from sharp objects or surfaces. You know, you could use old slings that we've cut up before, like especially synthetics. It makes for a great edge protector, synthetics does, or hose. So if you have hoses with holes in it, you know, we can recycle that hose and use for edge protection, but also we can use for transportating when we have to tie down stuff for load, stuff like that. So it's good edge protection, because that's what really you see a lot of failure in all of our rigging is because we're going around sharp objects, and that stress that we have is creating broken wires, is nicking the synthetics, or it's bending our chains. It's one of our biggest problems. So being able to identify that and using some riggings, hitches that we saw last week in the video, are good ways to prevent bending, chain, damaging synthetics, and breaking wires in our wire rope. Proper calculation of increased tension causes sling angles in all rigging components. Again, last week we had some good visuals on when we have to reduce our overall working load capacity. Again, the sharper this angle is, down to 30% with our, say it's a 2-way or a 4-way bridle system, we got to reduce our overall work load capacity because of our angles. The same thing with a choker. Remember, if you beat that choker down, that angle is supposed to be 120 degrees. This 120 degree angle, if you start really choking this down and this angle has now become something like this, this is your horizontal vertical line, or it'd be like this, I'm sorry. You just keep breaking that down, your overall working load capacity will go down. And a lot of that comes from this D over D ratio. Okay, this gets a little confusing, and it's important that if you have any questions on it, I can explain it more, but just quickly, I'll click on the link, and we'll just talk about just the D over D, because that's really in more technical rigging, with especially critical picks, stuff like this. This is where a lot of failures happen, is this D over D ratio. And a good rule of thumb is whenever we're using a shackle, because this is a kind of very common practice for us, whenever we're using the shackle, make sure the shackle diameter is no greater than the diameter of our wire rope. And a lot of this stuff comes from wire rope failures. Shackle should be the same dimension as your wire rope. When we're using it,
no bigger. Or?
Yeah, no, it's same size.
Shackle can be bigger.
Shackle can be bigger.
Right, correct. So
yes.
I want to make that.
Same size or bigger. Yeah, same size or bigger on the shackle than the wire rope.
Better on the shackle.
Yep, bigger is better. Now, true basket, we got to have that 25-to-1 ratio on a true basket hit. So that means the diameter of whatever you're picking up is 25-to-1 greater than your wire rope. And the reason for it is, again, it's those stresses that you're causing, because if it's too tight of a basket, everything, you're creating a lot of stress and pinch points on the wire rope. And that's when you see failures. And when the bigger you are, the more heavier everything is, the easier of a failure can be. So there's all these different tools. I mean, we don't use a lot of these different types of picks, but this is definitely one that we do very, very common, is with shackle rigging. And it's just always make sure that your shackle is bigger than the diameter of your wire rope. It's pretty easy to see, because everything should be labeled on it, so you should be able to tell from the wire rope what the diameter is, and then also a shackle should have an idea if it's a half ton or half inch, 3/4 inch, 5/8 inch, whatever it is on that. It's all stamped.
Matt, I think a good point on any of this, if you have to do any kind of reductions because of D over D,
That's good. Yeah.
you're going to end up wearing out the sling sooner.
Yes.
So it's better to just avoid that to preserve the rigging itself.
Yeah, that's a good point. And anytime, if you have any questions, get on the horn, call the safety department, call Ken, and we can come out and take a look. Especially if we're starting to see, a lot of quick wear and tear on rigging. Let's bring it to someone's attention so we can fix the problem, because a lot of it could be the way we're hitching. And then just calculate reduction when using the choker hitch, kind of like I said before. Be careful. Don't be banging those chokers down. You use that double wrap choker like you saw on the video. That's a great rigging technique to making sure you have good surface contact and you're keeping your working load limits to as strongly as possible. Keep personal and clear from all lifting area. Again, biggest thing. A good rule of thumb is when you need to work with tag lines, if the load becomes over shoulder length, we should start using tag lines. But if the load never really goes above shoulder, Taglines aren't necessary, but again, if you're flying stuff up and over, taglines should be used. And again, make sure no one ever should be underneath the suspended load. Lift loads a few inches when checking the rigging. Know your limitations of all lifting devices used. And lift slowly and stop slowly. Okay, never be in a hurry. Whenever we're picking and rigging, it's just nice, smooth controls. You know, operating just a loader and putting something on your forks and heading down this road or anything. Just again, slowly. There's a lot of potential energy when anytime we have low suspended, or we're using the crane, or even an excavator with you know, a trench box on it. Again, don't be in a rush. Things can happen very quickly, and there's a lot of stresses on our lifting devices. So make sure that we're thinking about all that stuff. And again, do your inspections. Okay? Do not use wire rope, synthetics, or chains if they've been damaged. Please take them out of service.
One other thing that wasn't mentioned here is just selecting the location for the crane or the excavator.
Yep.
Keeping that into the thought process to make sure you have the right radius and lift capacity of the crane.
Yep, crane pads. Plan your workout. Where's the crane going to have maximum working load limit where he's not going to be overreached? You know, knowing all that stuff, making sure the crane pad is, you know, level, free from all, you know, standing water, so it has to have some type of drainage. You know, that's a requirement now in the new crane standard that's coming out. I'll have more information on that in the next couple of weeks, as that's being kind of changed and modified a little bit. But any questions when it comes to rigging? We're going to get out of rigging next week, and so it kind of concludes our rigging training seminar. Hopefully we can keep seeing some good rigging techniques out there in the field. That's something I'm really keeping an eye on for. So
We didn't talk about signaling. Maybe that.
yeah, we could do signaling next week. Quick.
Maybe we should.
Yeah, we'll do signaling next week so everyone knows the proper hand signals. Okay. Yeah.
It's like you're milking a cow or something.
That's a one-handed signal.
All right.
Boom up and cable down. No, cable down. You're booming up and cabling down. So he's keeping the load at the same elevation, but he's moving it closer to the
The inch and a half cable. Most I count, I got like 4 broken strands in it. If you have another, you want to keep it so the manufacturer will get it, because that's for that one job. Where can I put it? It's on the hammer right now. Because the other day down there, I brought both of them. I used the flat. When I got back, I worked everything. Yeah. It's tucked over in the corner. When I loaded the hammer up, I got the flat one underneath. So it's on the sheet. That's how you work.
Yeah, I would like to work.
Okay. I mean, it's good for demonstration. 60 pounds, 70 pounds. I mean, it's so different.
The outside of the bridge, up on the old rivets. There's blocks. I got the idea we got to order at least 100 of them. He said, nah, let's go to 15 to start. He said, it should be easy to get. I don't think so. Let me get you the information. Okay. We want to set up an air manifold for air tools. What size diameter pipe they use? An inch or? So have a manifold right on the